Hello, good morning, everybody. Let's continue our lesson, shall we? So without annexation, we are going to start with chapter 4 for Sem 1. Okay, so these are the questions. So for questions, you can always refer to the books that you have already purchased. Okay. So with annexation, let's have a look at the questions. So let's start from question number 1. Which of the following properties is incorrect about ideal gas? So ideal gas in here should obey all gas law under any conditions. Okay, so therefore A is correct. However, so what are the two characteristics of an ideal gas? There shall be no intermolecular forces, number 1. Okay, and then the volume of all ideal gases are so small that can be negligible. So in here, the answer B in there is incorrect because it says that it can be attractive or repulsive. So it should be no intermolecular forces in here. Okay, and C is correct because the volume are so small that it can be negligible, and the mass of an ideal gas is constant under constant temperature and pressure. Okay, so therefore the answer which about incorrect about ideal gas in here is B. Okay, number 2, at 25 degrees Celsius, 40% of 1.0 mole of ammonia in a 24.4 decimeter cube contain 1 atmosphere. Decompose according to the equation. So this is the equation. So 2NH3 plus N2 plus 3H2. So what is the total pressure of the container after dissociation? So in here, you have to use the equilibrium logics in here, where initially you have 1 mole of gases. So how do you get 1 mole of gases? Because 24.4 under standard temperature, pressure, at 25 degrees Celsius in here is 1 mole. So that is how we know that it is in 1 mole. So when 40% of ammonia is decomposed, so you minus 0.4. So stoichiometrically, when the mole ratio of ammonia to nitrogen to hydrogen is 2 to 1 to 3. Okay, so you minus 0.4 or 2x. Okay, so nitrogen form will be 1x and hydrogen form will be 3x. Now this is according to the stoichiometry. So since 2x is equals to 0.4, therefore x is equals to 0.2. So since nitrogen is only 1x, so that is 0.2. And then hydrogen is 3x, therefore 0.6. So at the equilibrium, so the final mole of ammonia is 0.6, final mole of nitrogen is 0.2, final mole of hydrogen is 0.6. So total mole will be 0.6 plus 0.2 plus 0.6 will be 1.4. Therefore, at 1.0 atmosphere, the total mole, the number of mole will be equals to the total pressure in here. So the pressure that have lifted has become 1.4 atmosphere. So the answer in here is donkey D. Okay, so that is number 2. And then number 3, standard reference condition for study in the gaseous state of matter in the values are 298 degrees, 25 degrees Celsius, the standard reference condition for study of the gaseous states in here is actually 9 Kelvin and 1.0, which is 25 degrees Celsius, 1 atmosphere. So that is why the answer in here is D. Number 4, I have to admit that there is some mistakes in the question in here. That is why it's very hard for you to get the answer. So in here, actually, the answer is incorrect. So you might want to forfeit this question later. But technically, you use N1 over V1 equals to N2 over V2. So it's 12 times 2 of the molar mass of P plus M over molar mass of Q is equals to 1 volume. So in here, when the volume or when the mass of the gas P is double, so the mass has become times 2 over 2 plus M over Q. And then in here, the volume increased by 2. So in here is 2V1, 2V1. So at the end of the day, you get mass is equals to 10. But like I said, the answer is wrong. Okay, so there shall be no answer for question number 4. Okay. Okay, then we continue to number 5. Hydrogen fluoride is an example of a non-ideal gas under room condition. Why? Because hydrogen fluoride gas has what we so-called is this hydrogen bond. So because of its hydrogen bond, it has a strong intermolecular forces here. So that is why it is a non-ideal gas under room condition. Okay. Okay, number 6, the mixture of 5.0 mole of neon and 3.0 mole of nitrogen occupy a volume of 36.0 liter of a vessel where the total pressure is 6.0 atmosphere. Partial pressure of the neon in the container is how much? So you use the formula P neon is equals to mole of neon over N total times P total. You use the Dalton's law partial pressure equation. So partial pressure of neon is equals to 5 mole over the total mole 5 plus 3 times 6. So at the end, you get 3.75 atmosphere. Okay, so the answer in here is number D. Number 7, a quantity of 71 gram of chlorine is mixed with 32 gram of oxygen at 298 Kelvin and 101 kilopascal. Which statement best describe the mixture of the gaseous form? So in here, you have to understand both of the mole for chlorine and oxygen are the same because you divide by the molar mass. Okay, so you get the mole of chlorine is 1 mole, mole of oxygen is also 1 mole. So therefore, the number of particles that in here are actually the same. So what makes them different is because chlorine has greater mass compared to oxygen. So the average kinetic energy of the chlorine supposedly to be higher. But in here, if you look at the selection of the C in here, the number of molecule travel, okay, so which is the same. So therefore, the answer in here is the same. We are talking about number of molecule travel and average kinetic energy are supposed to be the same in here. Okay, so that is for question number 7C. Then number 8, Maxwell-Boltzmann distribution of a gas of an unknown is shown in the Maxwell-Boltzmann graph below. Which of the statement is true for this? So you have two different temperature in here, 273 Kelvin and 373 Kelvin. So which of the statement is true? Number 1, total surface area of both graphs are the same, which indicate that they have the same total number of molecule, which is actually correct. Okay, because when you have the same area, they indicate that they have the same number of molecules. So 1 is correct. Number 2, at a higher temperature, the peak of the graph shift to the right, not to the left. Okay, indicates that more molecule has a greater kinetic energy. So that is why number 2 is not correct because the graph shift to the right. Number 3, at a higher temperature, lesser molecule at average speed as the lesser molecule move at average speed as the peak become lower, which is true because when the peak become lower, that means that less particles has average kinetic energy. So 3 is correct. And number 4, at higher temperature, the base of the graph become broader, indicates that more molecule possess higher kinetic energy, which is also true because when you have a broader base, it means that more particles has energy greater than the kinetic energy. So therefore, they travel faster. Okay, so therefore, the statement number 4 is also correct. So the best answer in here is 1, 3, and 4, and the correct answer is B. Then number 9, which of the following graph is correct for a fixed mass of an ideal gas at a constant temperature? Now, if you look at the graph, all of them have the same cofactor, which is the graph of PV over V. So when you have a PV is a constant. Okay, so when PV is a constant, therefore, no matter how you change the volume, it's supposed to be constant for an ideal gases. So that is why the best answer in here is C. Then we have question number 10. At 1.0 atmosphere, pressure of ice, which is solid of water, floats in water instead of sinking. So why is it like that? So it is because when the water freezes, hydrogen bond in the ice become less stronger, therefore broken. So when this makes the particles inside the ice water become less strongly attracted and produce a large space volume. Hence, the ice expand as it freezes. So the best answer in here is A. So that's why when it is expanding, okay, the volume is greater. So when the volume is greater, the density decrease. So when density decrease, that is why it floats on the water. So the best answer in here is A. Number 11, supercooling defect is usually occur from liquid to become solid, where particles at the outer layer is first freeze while the inner layer rearrange slower than the outer layer. So that is why the best answer in here is C. Number 12, triple point of a substance in a temperature and pressure is at which all the solid, liquid, and gas coexist at the same time due to the sublimation, fusion, and condensation occur simultaneously. So that is why you have all these 3 states of matter at the same points in here. So that is why the best answer in here is B. Number 13, the diagram below shows the crystalline structure of a compound below. Now, if you study carefully the characteristic, the height and the length and the width are different. So two of the angles are the same and one is different. So these are all trying to describe the properties of monoclinic. Okay, so difference are not the same, different. So I'm trying to describe the properties of the triclinic. Okay, so in here, the best answer in here is C. So if all three angles are different, then it is a triclinic. Okay, so for number 13, the answer is C. This one you have no choice. You have to memorize the properties a bit on your own. I've already teaches you on how to memorize the technique, how to memorize the T structure. You can refer back to the YouTube for this chapter. Okay. Okay, so at number 14, at the temperature and pressure, point D, which statement is true? So in D, what happened at the point D in here? Okay, so substance will sublime, which is wrong because in here, this is solid, this is liquid, and this is gas. So this is the equilibrium line between liquid and gas. Therefore, substance is not sublime. It's either condensation or vaporization. So A is wrong. Right? In here, it is between liquid and gas, as I mentioned just now. So B is also wrong. Okay, so vaporization and deposition will take place simultaneously, which is actually wrong. And decondensation, evaporation will take place simultaneously. So the best answer in here is donkey D. Okay, then number 15, at temperature and pressure of point E, which statement is true? So this point E is the point where you have in between solid and liquid, in between solid and liquid. So substance with sublime is wrong. There will be an equilibrium between solid and gaseous, also wrong. Vaporization and depositions will take place simultaneously, which is also wrong. And the fusion and freezing will take place simultaneously, which is correct. So the best answer in here is donkey D. Number 16, starting at the temperature and pressure of point C, if the pressure is increased. So what happened in point C? Let's have a look. This is the point C that they are trying to describe. So this is the point C. So if you look carefully in the point C in here, if you, okay, sorry, I draw the line a bit. And okay. Okay, so what happens if you keep increasing the pressure in here? So if you keep increasing the pressure from the point of C, so what will happen is okay, so let's have a look. So if the pressure is increased, so it changes from gas to become liquid. So therefore from gas to become liquid is a process of condensation. Okay, so the best answer in here is donkey D. Okay, so that is for number 16. Then we go to number 17. Two liquid S and T at the same volume were allowed to evaporate under temperature pressure. After 30 minutes, it was found that the volume of the liquid S decreased more than the liquid T. What can be concluded from this observation? So if a substance volume of the liquid decreased more, it means that S is more vaporized or easier to vaporize. That means S is more volatile. Okay, so therefore answer number 1 is correct. Number 2, when a substance is easily vaporized, it means that the vapor pressure of S is higher than T. So therefore number 2 is wrong. Okay, and then number 3, intermolecular forces of S is weaker than the T. That is the reason why it's vaporized easier. So number 3 is correct. And number 4, liquid S has a lower temperature boiling point than liquid T at under temperature pressure. So that is why the number 4 is also correct. So the best answer in here is 1, 3, and 4, C. Okay, number 18. How many atoms per unit cell are there in the body center cubic lattice? So in the body center cubic lattice, do I have the diagram for this? So I didn't attach. So you can refer back to the YouTube for the body center cubic. So for body center cubic, it is made of 8 corner plus 1 center body particles. So that is why the formula will be 1 times 1 plus 8 times 1 over 8. So total number of particles will be 2. So that is why the answer for number 18 is B. Number 19, a manometer is a device for measuring gas pressure. Sample of nitrogen gas is placed in a closed-end manometer at 25 degrees Celsius until there is an increase of 0.1 gram in this mass. Diagram below shows the height of the mercury in the manometer. What is the volume of the nitrogen gas in the manometer? So given to you, molar volume of gas is 8.31 joule Kelvin minus 1 mole minus 1, and 760 millimeter mercury is equals to 101 kilopascal. So since the question in here gives you in terms of the millimeter mercury, so you have to somehow change to become kilopascal, because the molar volume of gas in here is given to you in joule, Kelvin -1, mole -1. So if you see this unit, you must understand by yourself that the pressure must be in the unit of this Pascal, whereas the volume must be in meter cube. Okay. So how are you going to solve this? So first of all, you have to first minus what is the difference of the height. So 600 minus 100, you get 500. Okay. So 500 millimeter mercury divided by 760 millimeter mercury, so you get 66.44 kilopascal. Then you use the ideal gas equation, PV equals to nRT. So the because it's nitrogen gas, you have to know by yourself this is nitrogen gas. Okay, so nitrogen gas, you have to find the mole. So 0.1 divided by 2 times 14, which is 28. So you get 3.5714 times 10 power of 3 mole. Then you apply to PV equals to nRT, where V is equals to 3.51714 times 8.31 times 298 divided by 66.4 times 10 power of 3 Pascal. So press your calculator, you get your volume is equals to 1.33 times 10 power negative 4, or simply 133 centimeter cube. So the best answer in here is C. So this is how we calculate for question number 19. As for question number 20, phosphorus pentachloride decomposed according to the equation, PCl5 gives PCl3 plus Cl2. When 1.3 times 10 power negative 2 mole of PCl5 is heated at 727 degrees Celsius in 1 decimeter cube flask, the total pressure formed is 150 kilopascal. So what is the partial pressure of the chlorine flask in here? So in here, because this system is an equilibrium, that means not all PCl5 will be decomposed. So you have to first find out what is the total volume of the gas, what is the total mole of the gases at the end of the day. So first of all, you have to use the PV equals to nRT equation to get your total number of mole. So at 150 kilopascal, so 150 times 10 power of 3. And as I told you, if you use PV equals to nRT, your volume must be in meter cube. But in here, the volume is 1 decimeter cube vessel. So from decimeter cube to become a meter cube, you have to times 10 power negative 3 lah. So that is why you get 150 times 10 power of 3 multiplied by 1.0 times 10 power negative 3 equals to number of mole, total mole of gases, times molar volume of gas times the temperature, 273 plus 727 degrees Celsius. So you have to convert to become Kelvin. So once you get that, the total mole will be equals to 0.018 mole. Then you have to back to the equilibrium system where PCl5 is give PCl3 plus Cl2. So initially you have 1.3 times 10 power negative 2 mole PCl5. So some PCl5 will dissociated, and the stoichiometry is 1 to 1 to 1. That means one PCl5 will dissociate to become 1 PCl3 plus 1 Cl2. So at equilibrium, you have 0.013 minus X, and then you have plus X and plus X in here. So total mole at equilibrium will be 0.18 as we calculated just now using PV equals to nRT. So 0.13 minus X plus X plus X. Okay, so minus X plus X will be 0. So move the 0.13 to here. That is why you get your X is equal to 0.05. So now we want to calculate the partial pressure of the chlorine gas. So partial pressure of chlorine gas in here is 0.05 mole. So PCl2 is equals to XCl2 by P water. So 0.05 times 0.018 times 150 kilopascal, you get 42 kilopascal. So the best answer in here is C. So that is how you calculate for question number 20. Yeah? Okay, 21. The Boltzmann distribution curve at temperature T1 and T2 are shown below. So you look at carefully at the area, both areas are the same. And in here, the peak of the T2 shift more right than T1, indicates that T2 has a higher temperature, or T2 has a lighter gas compared to T1. So what is true about T1? Number one, at T1, activation energy is lower than T2. So in here, activation energy is actually the same. Okay, it's just that more particles in T2 has an energy greater than the activation energy. Okay, so more molecule has a lower energy, which is correct. Okay, and then number C, total number of molecule is greater, which is incorrect because we are the same. And then enthalpy change of the reaction is lower, which is also not correct. because under the same for the same species, they have the same enthalpy change of the reactions in here. So the best answer in here is boy B. Okay, number 22. The phase diagram of water is shown below. What can be deduced from the phase diagram in here? So if you look carefully, they are all sloped to the right in here. Okay, so they are all sloped to the right in here. So what can be deduced? So what happens when you increase the pressure? So when you increase the pressure, let's say if you increase the pressure from here, I'm going to draw. So you will increase the pressure in here. So what will happen is, as the pressure increases, okay, I show here lah. Okay, so you will find out that it will become more and more like liquid. Okay, so it behave more and more like liquid. That means the freezing point will eventually decrease in here, increase in here. Okay, so decrease in here. Sorry. So when you increase the pressure, you will decrease the freezing point of the water. Okay, so this is the anomaly type that happens when it comes to the water. Because usually when you increase the pressure for other substance other than water, you are supposedly to make the substance behave more and more like a solid. Okay, so because all the slope, this melting point curve slope to the right for other species, but for water it's slightly different in here. Okay, so that's why we say that the freezing point is actually decreasing for water. Okay, so as for answer B, an increase in pressure will decrease the boiling point. So here the effect of the boiling point is still the same, because there is no difference in curve for the vapor pressure sublimation, vapor pressure curve. So they are supposed to be the same. So B is wrong. And then for C, ice sublime at the pressure higher, in here, instead of sublime, we said that it's melt. Okay, and water exists as a liquid at the pressure of 6.1 611 pascal and 98 kilopascal. So if you look carefully, it is here 611 kilopascal. 611 pascal and 298 Kelvin is here. So instead of liquid, it is a gas. Okay. So when it is a gas, so that is why D is also wrong. So the best answer in here is A. Okay. So that is for question number 22. Then for 23, two liquid X and Y at the same volume are allowed to evaporate. It is found out that X evaporates first before Y. Which statement is best explained? So when the substance evaporates first, that means that X has a higher vapor pressure. Okay. So vapor pressure of X is higher compared to Y. Okay. So A is wrong. So for B, intermolecular forces of X is weaker than Y, which is true, because when you have a weaker intermolecular forces, it vaporizes easier. So B is true. C, density of Y is higher than X. So this, we do not have any information that says that density will be higher than which one, because in here, vapor pressure in here has nothing to do with the density. Okay, and last but not least, Y is more viscous than X. Y is more viscous than X means that in terms of viscosity, that means the flow of the liquid. Okay, so supposedly you have a greater intermolecular forces. So when you are greater intermolecular forces, so it is less viscous. That means it flow less smoothly than the X. So therefore, D is also wrong. Okay, so therefore 23, the best answer in here is boy B. 24. 52 centimeter cube flask is filled with a gas at 200 degrees Celsius. Pressure produced is 129 times 10 power of 3 Pascal. If the temperature is then increased to 400 degrees Celsius, the pressure increased by 3.68 times 10 power of 3 Pascal. Which statement is true about this observation? So number one, the gas obeys Boyle's law. Does it really obey Boyle's law? We can't really tell whether it obeys Boyle's law because the volume of 3.68 times 10 power of 3 is not given. Okay, so A is wrong, and there are no evidence showing that the gas exists as a dimer. Since using PV equals to nRT, it can only give 1.71 times 10 power of 3 mole of gas, but not the molar mass of B. So number of the gas for molecule cannot be calculated since the information is not enough. So C is also wrong. While using D, P1 over T1 equals to P2 over T2. So that is the derivation when you combine between Boyle's law and also Charles' law. So the number of collision with the wall of simply pressure is double when the reaction increased to 400 degrees Celsius, where 1.29 times 10 power of 5 divided by 200 times 273 is equals to 2 times 3.8. So you can see that it is double. Okay, so the best answer in here is donkey D. So that is how you solve for question number 24. Then 25, a mixture of hydrogen gas and nitrogen gas in a container is maintained at a pressure 200 atmosphere and a temperature 450 degrees Celsius. Which factor contribute to the deviation of the ideal gas in here? So now you have high pressure. For a gas to behave ideally, you must have high temperature, low pressure. However, in here the pressure is relatively high, so that is why it is when you have high pressure, okay, eventually you build what we so-called as the attraction forces. So when there is attraction forces in between hydrogen and nitrogen, so that is why it will make the gas become less ideally behave. So the best answer for 25 is A. Number 6, the density of the potassium and copper are 298 Kelvin. At 298 Kelvins are 0.86 gram per centimeter cube and 8.94 gram per centimeter cube respectively. Which of the following statement explain the difference in the density of two metals? So when you have difference in density for a solid, we are now talking about solid, so it depends on how you arrange the particles. So if the particles has small number of particles per unit cell, so that is why they are more dense. So this happens in the case for copper. For the case of copper, so copper has in the A statement A, potassium have a body center cubic, while copper has a face center cubic. So body center cubic has two particles per unit cell, while face center cubic has 4 particles per unit cell. So this is the reason why potassium has a lower density compared to copper in here. Okay, so that is the best explanation why is it that the copper has a higher density compared to potassium. So it is based on the number of particles per unit cell. Then we have 27. Ideal gas obeys the following law except for which law? So ideal gas follow ABC law, which is Avogadro's law, Boyle's law, and also Charles' law, but not Raoult's law. Raoult's law has nothing to do with the ideal gas. Okay. 28. Diamond, graphite, and fluorine are all allotropes of carbon. Which statement is true about these three allotropes? Number 1, they are good electrical conductors, which is actually wrong. Only graphite and fluorines are. They form carbon dioxide on complete combustion, which is correct because when you burn, all of them will eventually become carbon dioxide only. Okay, they have sp2 hybridized orbitals of their carbon atom, which is wrong because diamond is sp3 while the rest is sp2. And then number D, they have a strong covalent bonding and weak van der Waals forces, which is wrong because only graphite has that. Okay, so diamond and fluorine don't have. So the best answer in here is 4AB. Then 29, which statement is or are true of water in a solid state? So each atom in the oxygens in here is bonded to 4 other hydrogen. In here they only say bonded. They do not specifically say either covalent bond or hydrogen bond. Okay, so that's why number 1 is correct. Okay, then number 2, it has a covalent bond and a hydrogen bond, which is it has covalent bond and hydrogen bond, which is actually correct because in between hydrogen and oxygen, they both are held by either covalent bond or hydrogen bond. Now it has a tetrahedral structure, which is also true because in here, the way of how water arranged in here, they are arranged in a tetrahedral structure. And finally, it has a greater density than water in liquid state, which is wrong because ice is less dense than water. So the best answer in here is 1, 2, and 3. Number 30, fullerene is one of the carbon allotrope which is used as the base to study for carbon nanotube and its technology. Which statement about fullerene is not true? Number 1, all of its carbon are sp2 hybridized, which is correct. And then since it is sp2 hybridized, definitely it contains a delocalized electron, which is also correct. The bonding angle of the fullerene is 120 because it's all sp2 hybridized, and it has a higher density than diamond, which is wrong because diamond is sp2 hybridized, is bonded to 4 other carbon atoms. So supposedly the density of the diamond is greater than that of the fullerene. So therefore D is wrong. Okay, so the best answer in here is donkey D. So that is for number 30. Yeah? Then for 31, flask X contains 5 decimeter cube of helium at 12 kilopascal pressure, while flask Y contains 10 decimeter cube of neon at 6 kilopascal pressure. If the gas are connected under constant pressure, what is the final pressure? So in here you use P1V1 equals to P2V2. So for X, because they are connected, so you have to recalculate the pressure for both X and Y. So 12 kilopascal times 5 decimeter cube equals to A. Is equal times 5 plus 10. So because you connected, total volume will be increasing. So A will be 4 kilopascal. As for gas Y, 6 kilopascal of in 10 decimeter cube connected to A times 5 plus 10. So therefore A is also 4 kilopascal. So as a result, total pressure is 4 plus 4, which is equals to 8. So the best answer in here is A. Number 32, PQ and R represent 3 different structures of an element. P is actually graphite, Q is actually diamond, R is actually fullerene. Which substance has a giant molecular? So in here, due to the Q is definitely a giant covalent, okay? While R in here, because it is a hole inside a ball sphere in here, so it contains maximum 60, so it is not a giant covalent. While P is a paper sheet-like structure where it is held by many carbon atoms, so that is why it is also considered as a giant. So P and Q are giant, while R is not a giant. Okay, so therefore the best answer in here is B. Number 33. In this question, you should assume methane behave as an ideal gas. The volume example of methane is measured at temperature 60 degrees Celsius, pressure 103 kilopascal. Volume measured at 5.73 times 10 power of 3 meter cube. So what is the mass of the sample of methane? So you use PV equals to nRT, or simply mass is equals to nR times PV over RT. So you substitute all the value is inside there. You get 16, which is the molecular mass, times the pressure 103 times 10 power of 3 pascal, and then volume is 5.73 times 10 power negative 3 meter cube over 8.31 times 273 plus 60. So at the end you'll get your mass is 3.2. So the best answer in here is C. As for 34, complete combustion of 2 mole of straight chain of alkane produce 400 decimeter cube of carbon dioxide measured at 301 Kelvin and 1 times 10 power of 5 Pascal. Carbon dioxide can be assumed to behave as the ideal gas under this condition. What is the formula of the straight chain in here? So you use PV equals to nRT to calculate the mole of carbon dioxide. So mole is equals to PV over RT. So N is equals to 1.0 times 10 power of 5 times 0.04 divided by 8.31 times 301, which is 16 mole. So since 2 mole of the hydrocarbon produce 16 mole of the carbon dioxide, therefore X is 8. So therefore the best answer in here is A. That is for 34. And then we go for 35. The sample of an ideal gas is contained at a constant temperature 300 Kelvin in a gas switch. The pressure increase of a graph of RT against PV for the graph is plotted. So now what is the graph is correct? The question already mentioned that the sample is an ideal gas. So for ideal gas, no matter how you increase the pressure, the graph is supposed to be constant. So the best answer in here will be C. Okay. So there you have all the answers and the solutions and how to tackle the objective questions is already given to you. So I shall see you in the next lesson. We will discuss about structure question for this chapter. Okay, so any question you can leave a comment in the YouTube, and I'll try my best to reply to you one by one as much as I can. Okay, so I guess that is all for our lesson today. So I see you all on our next lesson. Okay, so goodbye.